All right, let's do this. So, what did we do yesterday? We did ratios yesterday, and only ratios. Obviously, if we did ratio yesterday, what does that mean we are going to do today?
Percent.
Look at the screen.
Ratio?
If we did ratios yesterday, today we're doing proportions. So, are we ready to learn what proportions are? What's the point of proportions? Are we ready to learn what that is? So, proportion. The definition of proportion, because I notice a lot of students love definitions, is this. A proportion is an equation that shows that two ratios are equal. So, what does that mean? Well, how about we see it visually? So here we have two cars. Two cars, right? And the problem is this. Actually, before we get into the problem, these are proportional to each other. As in, one might be smaller, but if you were to have some magical machine that would get a small little Hot Wheel toy car, and you just expand it, and it become this, it's technically the same thing. One is just bigger than the other. They're proportional to each other, right? It's similar to the fraction idea. If we had 1/2, 1/2 was the same as 8/16, right? They're both the same. It's just that one is bigger. It's the same scenario here. Here we have two things that are proportional to each other. That is what proportions mean. Now, it's a lot more than just understanding the definition of proportion. It's a lot more than just visually seeing it. It's about learning proportion problems. This is what I mean. So this is the type of problem that you're going to see for those of you taking your GED and taking my quiz. The thing is, the word problem is like this. A car engineer person is working on the latest model for the next year's Volkswagen, right? He or she is making the design, making it out of clay, making a miniature scale model of it. And it's that one right there. Then once the engineer is done with the miniature scale model, he or she measures the height of it, and they realize it's 3 inches high and it's 5 inches long, right? They take it to the car company. The car company approves it to make the actual design of the car for the next year's model. So they design it and they make the actual car, and it's this one right there. And what they realize is it is 7 feet long. Go for it. Take as much as you want. It is 7 feet long, right? But the question is this: how tall is the real car? If we know the miniature scale model is 3 inches tall, if it's 5 inches long, if the real car is 7 feet long, how tall is it? Knowing that they're both equal to each other, they're both proportional to each other. How tall is the real car once finished? Well, my friends, this is when we use proportions. So what's proportions? Easy. You set up two ratios across from each other. So what's the first ratio that we're given? 3:5, right? Let me make this smaller so we have more space. We have 3 and 5, right? That's the first ratio that we were given. You're always going to be given a problem. You're always going to be given a ratio, right? But now it's up to you to determine where your third number goes. Over here we have x and 7, right? It's up to you to determine where the 7 goes, whether up top or the bottom. In order to know that, you must ask yourself, what do these represent? What does the 3 represent? What does that 3 stand for? Is it showing you how long the car is or how tall the car is?
Height.
Exactly. The 3 represents your height. What does the 5 represent? Length. Right? So that's our first ratio, height and length. This whole top part is designated now for the height. And this whole bottom part is designated for the length. So when they ask us, what is the height of the car when the length is 7, where should the 7 go? On the bottom, right? Because the bottom row symbolizes my length. So, the key is to set up your proportions next to each other. You're always going to be given your first ratio from the problem, 3 and 5, right? So we set it up 3 over 5. You're always going to be given at least one ratio complete, okay? As for the other ratio, one piece is missing and one number is given, right? You must find out where it should go. Should it go to the bottom or go to the top? Well, just ask yourself, what does the 7 represent? That 7 from the problem symbolizes the length of the new car, right? That's what I said. The 7 represents the length of the new car. So ask yourself, where should the 7 go? Let's say we didn't write it there. The only way to know where it goes is by what these represents. And we asked ourselves, what does the 3 represent? The 3 represented my height of the miniature model, right? The 5 represented the length of the miniature model. So if you notice, the 7 should be across the 5, the other length, right? And what we're looking for is our height. you want to set up your proportion problem like this. All we're doing right now is setting it up. That's all we're doing. We're just setting it up. We're putting it in its designated areas and nothing else so far. But so far, did that make sense? Did it make sense? Did it make sense?
Yeah.
So we're going to come back and solve this. We're going to find x. We are going to find it. But here's another problem to set up. Because remember, all we're doing is setting it up so far. This is another problem. So, this is a word problem right here. I'm making it up. A fruit basket has, for every 3 tomatoes, it has 5 bananas. Right? Was that the same that I just did? Yes, it was. Oh my God. No, let me change it up. In a fruit basket, for every 2 tomatoes, there are 4 bananas. For every 2 tomatoes, there are 4 bananas. How many tomatoes are there in a bigger fruit basket that's proportional to the smaller one? How many bananas are there if there are 16 tomatoes? Where should my 16 go? That was the other number, right? Right?
Yeah.
You were listening. Were you? So in a fruit basket, a small fruit basket with fruits in them, this is a little handle. It has, for every 2 tomatoes, there are 4 bananas. How many bananas are there in a fruit basket with 16 tomatoes? Well, you have your first ratio, 2 tomatoes for every 4 bananas. And they want to know how many bananas are there if you have 16 tomatoes. Where should that 16 go? Where should that 16 go? The top or the bottom? That's all you got to worry about right now. Where should the 16 go?
On top.
Can I ask why?
As you said, for every 2 tomatoes, there's 4 bananas.
4 bananas, right? This top part, this whole part right here, represents the tomatoes. Which means this bottom part represents my bananas, all this. And that's what they're asking for. They want to know how many bananas are there in a fruit basket with 16 tomatoes. That's called the setup. This right here, what we're doing is setting up our proportion. That's all we're doing. With that one and this one. We're setting it up. That is 100% the hardest part to proportions. 100% the hardest part of proportions is the setup. The fun part is now to find x. Do you guys want to learn how to solve proportions?
Yeah.
We set up proportions. Now are we ready to solve proportions? Easy peasy. All you must do is look for the numbers that are across from each other, right? The 2 and the x, that can't be done because 1 is an x, right? 4 and 16, you found it. The 2 numbers across from each other, a diagonal from each other. what you do is multiply that. 4 times 16. You will be able to use a calculator for this, by the way. 4 times 16 is, I'll let you figure it out. What is 4 times 16? 64, right? You get that number, and then you divide it by the 2. What's 64 divided by 2? 64 divided by 32 is, 64 divided by 2, my bad, is 32. Guess what? You just found the missing piece. There are 32 bananas in a fruit basket with 16 tomatoes. So what did we conclude? We cross multiply. You divide by wherever the third number is, and you found your answer. So how about we go back to our car problem, and we find out the height of our new car.
3 times 7?
Yes. 3 times 7, whatever that answer is, you then divide by 5. What's 3 times 7?
21.
What's 21 divided by 5? 4.2, huh? 4.2 feet tall. That's how big the car is. Tall, I meant. That's how you solve proportions.
And, okay, so times 3 times 7.
Whatever that answer is, you then divide by 5.
And then you take the 5 and divide it.
No, the answer, the product of your diagonal, so 3 times 7,
21.
that answer you divide by 5.
21 divided by
21 divided by 5, yes.
Okay.
Not 5 divided by 21. You'll get a completely wrong answer. This is how you solve proportion problems, you guys. So they'll give you the picture, or they won't. They'll give you a word problem. It's up to you to find it. This is a good one. This is a word problem right here. Are you ready? A map scale says that 2 inches equals 150 miles. So a map on paper, for every 2 inches, it equals 150 miles in real life. What actual distance would a map distance of 5 inches represent? So again, for every 2 inches, it equals 150 miles in real life. What's my first ratio that was given?
2 inches equals 150.
2 over 150, right? We're always writing it as a fraction. So for every 2 inches, it equals 150 miles. The question is, how much would a distance of 5 inches be? So where should the 5 go?
With the inches, which is 2.
Which is the top, right?
Yes.
Do you see that? The 5, they say how many miles would 5 inches depict on the map? So the 5 goes up there, and guess what? I'm looking for how many miles there are. You must set it up first like this, you guys. Set up your problem like this. The setup is the most important piece for proportions. Guess what? Now solve for x. Solve for x. What must I do? Guide me. What should I do?
150 times 5.
I know you were. What's 150 times 5 though?
750.
Cool.
By 2.
Yep. 750 was 150 times 5. 150 times 5 was 750. You then divide 750 by 2. What's 750 divided by 2?
375.
Guess what? My x equals 375. So 5 inches on this map in real life is 375 miles. Do you see the importance of proportions? Do you see it? Do you? Well, do you? So, the setup is key, that's A. B, you solve for x, which is cross multiply, then divide by wherever the third number is, and then find your x. So are we ready to do this?
Yeah.
Are we ready to show our skills via practice problems? Let's do this.